In this video, we want to talk a little bit more about some kind of free response ideas, and start here with just a little bit about velocity and using that to do distance and displacement. So a particle moves along the x-axis so that its velocity at time is given by the equation v of t equals 6t squared minus 18t plus 12. Find the total distance and displacement. Well, displacement is usually the easier one here, because displacement, all we have to do is integrate velocity. So 6t squared minus 18t plus 12, and that's it. I mean, this is the easier one to do. So my antiderivative will be 2t cubed minus 9t squared plus 12t, evaluate at 4 and 0. And if I plug in 4, I would get 32. If I plug in 0, I get 0. So the answer is just 32. This is displacement. Now distance is a little more work, because in this case there is going to be some forward and backward movement. And if I factored that velocity equation, okay, velocity, I'm going to start by just taking a 6 out of everything. So t squared minus 3t plus 2. So I could do a little more factoring and say it's 6 multiplied by t minus 1 and t minus 2. So what I see here is zeros, or sign changes, at 1 and 2. And it is a parabola, so I could do some sign analysis, but let me just make a little sketch here. Here's 1, here's 2. What I think this thing is going to look like is it's going to come down, cross, cross, and go back up. And of course I was looking for the area at 4. So I'm going to have some positive area, some negative area, and some more positive area. Well, I need to then break this integral into 3 separate, distinct parts. So I'm going to have one integral, and it's the same integral. It's the same. It's 6t squared minus 18t plus 12, but different bounds. So let me just kind of skip that step. Let me go to the antiderivative. And let's evaluate at 1 and 0. Let's start with just that first little bit of positive area. So if I plug in 1, I get 2 minus 9, which is negative 7, plus 12, which is 5. Plug in 0, I get 0. So the answer is 5. So this area right up here is 5. Okay. Well, now let's do the same exact thing, or same exact antiderivative, except this time let's plug in 2 and 1. When I plug in 1, I get 5. I've already done that. When I plug in 2, well, 2 multiplied by 8, 16, minus 9 times 4, so 16 minus 36 is negative 20, plus 24 is 4. So 4 minus 5 is negative 1. Well, this is the area that goes right up in here. And finally, same antiderivative. This time I'm going to evaluate it 4 and 2. Well, I plugged in 4 earlier, I got 32. And I plugged in 2 in the previous part, I got 4. So this is 28. So this area is 28. Now remember, distance says, well, ignore the negative, just add them up. So the total distance traveled is 5 plus the absolute value of negative 1 plus 28. So the distance traveled is 34. Now I just briefly wanted to talk about this this free response question, because it is such a common question type on the AP exam. You see, we have the rate at which people enter an amusement park, modeled by that equation. The rate at which people leave the amusement park is modeled by that equation. They're measured in people per hour, and time is measured in hours after midnight. Their functions are valid from 9 to 23 because that's when the park is open. At time 9, there are no people in the park. I guess I don't necessarily want to get all the answers here, but I do want to talk about some strategies. And I guess my first strategy would just be to tell you, put these in your calculator. This is a calculator question. Like, put this in y1, put this in y2, so you don't have to type the equations over and over again. Part A says, how many people have entered the park by 5 p.m.? Well, how many? Remember, we have a rate. So if we want how many, we need to integrate. So we're going to do the integral of e of t dt by times 17. Well, again, the park didn't open until 9, so 9 to 17. That would be our integral. We just use our calculator, fn int, and solve that. Next, it says the price of admission is $15 until 5 p.m. So really, and I can say that this answer came out to be 6,004. Okay. So for part B, I say, well, okay, we had 6,004 people come in and they paid $15. Well, then it says after 5 p.m. the price of admission is $11. Okay, well then we had more people enter. How many more? Well, I'd have to integrate from 17 to 23, from 5 p.m. to the park closes, and I'd multiply that by 11. It comes out to be like 104,000 if you do it, but again, it's not too bad. You just gotta be careful with what you're given and what you need. We have a rate. We want how many, so we got how many people entered from the beginning of the day to 5 p.m. We figured out how much they were charged. Then we figured out how many people entered from 5 till apparently 11, the time the park closed, and then we figured out that they were charged 11, and we add them up for the total cost. Okay. Part C says let h be the integral from 9 to t of e to the x minus L to the x. Well, you can think about this. Let me just kind of sketch this down here. You can say that h of t is the integral of e to the x minus the integral of L to the x. Okay, I better put my dx's on there. Now, we can do that because they had the same bounds. They were both 9 to t. And sometimes this helps people say, oh, okay, so it's the amount that came in minus the amount that left. This is the total amount in the park. Okay. At time t. So then they say, well, h of 17 to the nearest whole number is 3,725. Find the value of h prime and explain the meaning of h of 17 and h prime of 17. Well, h prime, if I took the derivative, h prime of t right here, that means I'd take the derivative of the integral and I'd just get the function. That's that fundamental theorem, part 1. So here, all I should have to do is plug 17 into the first equation, 17 into the second equation, find the difference. If you do that, I think it comes out to be negative 380 and something. Now, explain the meaning. Well, h of 17, right, the integral, h was the integral. This is the total amount of people in the park at time 17. You need to be very clear because h of t is the total amount of people in the park. H of 17 is the total amount of people in the park at that time. You need to say at that time 17 to get credit. That says, what's h prime? Well, remember, the derivative is a rate. So this is the rate at which the number of people in the park is changing at time 17. And again, if the question was, what's the meaning of h prime of t, you'd say, well, it's the rate at which the number of people is changing. But since it's h prime of 17, you have to say at time 17. Okay, so you got to be very careful with your wording here, that because it's not just, hey, what's the meaning of h of t and what's the meaning of h prime, they gave you a number. You must use that number in your explanation. At that time, time 17, it was the number of people or the rate of change. Okay? At what time does the model predict the number of people in the park is at a maximum? Well, a couple ways to think about this. One way, let me just create myself a little room here, is to think about the fact that if you were to graph kind of your just logical sense of what's happening at an amusement park, okay, throughout a day. Like here's 9 a.m. Here's the end of the day. Okay, this is just my logic. This isn't the real graph. This is my logic. Here's what happens. A lot of people start coming in right away in the morning. Okay, a lot of people come in. As the day wears on, less people start coming in until you get down to the end of the day when no one's showing up at, 10:58 when the park's open for 2 more minutes. So it tails off. On the other, okay, so this is the entry. Okay. Now, the rate at which people are leaving, well, at the beginning of the day, no one's leaving. They're all there. They get in the park and they stay. But as the day wears on, more and more people are going to leave until you get to the end of the day when everyone has to leave. Well, logically, doesn't it make sense that the maximum amount would occur when these two things intersect one another? Because as long as the rate of entry is bigger than the rate at which people are leaving, more and more people are coming into the park. But at this point, this blue dot, now more people are leaving than entering. So the amount of people that we have in the park is decreasing. So it's at the intersection point. So one way to think that this is the spot where the entry rate and the leaving rate cross. They're equal, they intersect. The more calculus way to think about it is to think, well, I want to know when the amount is at a max. Maximums occur at endpoints or critical points. Critical points are where the derivative, h prime, is equal to 0. Well, the derivative, look at h. H was the integral of e minus L, so the derivative of h is equal to e minus L. And we set that equal to 0 because we want to know where the critical point is. Okay, so let me just do that again. Let me just talk through it. We have an equation for amount, and we want the maximum amount of people at the park. Maximums occur at critical points or end points. Of course, it's not going to occur at 9 because there's nobody in the park, and at time 23, nobody should be left in the park. But so we shouldn't worry about endpoints too much. So we got to look at the critical point when the derivative of amount is 0. Well, it said derivative was equal to the integral. So the function. So the derivative of h. Derivative of the integral's gone. It's just e minus L. Now I want you to just notice that these two statements say the same exact thing. One says that, you're going to hit your maximum when the two intersect, they cross one another. This one says you're going to hit your maximum when the difference between them is 0. But that's saying exactly the same thing. So what you would do is graph the two equations and either look for where they intersect or graph, y1 minus y2 and just see when it crosses the axis. And that will give you the time at which the amount of people is at a maximum. And a couple ways to do it.